Welcome back to JVM Internals Crashcasts. I'm your host, Sheila, and today we're diving into an exciting topic, Kubernetes and JVM applications. We're currently in our Beyond Expert season, exploring advanced topics and future directions for the JVM. Victor, are you ready to help our listeners navigate the world of Kubernetes and Java?
Absolutely, Sheila. I'm excited to explore how these two powerful technologies work together. This is a crucial topic for any Java developer looking to deploy applications in modern cloud environments.
Great. Before we dive in, let's set the stage for our listeners. We're assuming you're familiar with basic JVM concepts and have some understanding of containerization, particularly Docker, which we covered in our previous episode. Today, we'll be building on that knowledge to explore how Kubernetes orchestrates JVM applications. Now let's kick things off with a quiz question for our listeners. Victor, would you like to do the honors?
Certainly. Here's a question to get our listeners thinking. In a Kubernetes cluster running JVM applications, what's the primary challenge when it comes to resource allocation for Java applications, and why is it different from other types of applications?
Ooh, that's an intriguing question, Victor. It really makes you think about the unique characteristics of Java applications and how they interact with container orchestration systems. I'm sure our listeners will be pondering this as we go through the episode. Now, let's start with the basics. Victor, can you give us a quick overview of what Kubernetes is?
Of course, Sheila. Kubernetes, often abbreviated as K8, that's K, followed by 8 letters and S, is an open-source container orchestration platform. Think of it as a highly efficient factory manager for your containerized applications. Just as a factory manager coordinates different assembly lines, workers, and resources, Kubernetes manages containerized applications across a cluster of machines. It automates deployment, scaling, and management of these applications, ensuring they run smoothly and efficiently.
That's a great analogy, Victor. It really helps visualize the role of Kubernetes. So, how does this factory manager, Kubernetes, handle JVM applications specifically? Are there any special considerations?
Excellent question, Sheila. When it comes to JVM applications in Kubernetes, there are indeed some special considerations. The JVM has its own memory management and garbage collection mechanisms, which can sometimes conflict with how Kubernetes manages resources. For example, the JVM might see all the resources available on the host machine, rather than just what's allocated to its container. This can lead to issues with memory allocation and garbage collection.
That's fascinating, Victor. It sounds like there's potential for miscommunication between the JVM and Kubernetes. How do developers typically address this issue?
You're right, Sheila. This is where proper configuration becomes crucial. One common approach is to use specific JVM flags to make it container-aware. For instance, using flags like AliXX, use container support, and XX max RAM percentage can help the JVM understand its container environment better. Additionally, setting appropriate resource requests and limits in Kubernetes helps ensure the JVM doesn't overcommit resources.
That makes sense. It seems like there's a delicate balance to strike. Speaking of balance, can you tell us about some of the benefits of running JVM applications in Kubernetes?
Absolutely. Running JVM applications in Kubernetes offers several advantages. First, it provides excellent scalability. Kubernetes can automatically scale your Java applications up or down based on demand. Second, it offers improved resource utilization. By packing multiple containers onto the same host, you can make better use of your hardware resources. Lastly, it provides built-in features for high availability and fault tolerance, which are crucial for enterprise Java applications.
Those are compelling benefits, Victor. But I imagine there are also some challenges. What are some common pitfalls developers should be aware of?
You're right to ask about challenges, Sheila. One common pitfall is underestimating the importance of proper resource configuration. If you don't set appropriate CPU and memory limits, your Java applications might become resource-hungry neighbors, affecting other containers on the same node. Another challenge is managing application state, especially for stateful Java applications. Kubernetes is designed primarily for stateless applications, so managing state requires careful planning.
Those are important points to keep in mind. Now let's shift gears a bit and talk about best practices. What advice would you give to developers deploying JVM applications on Kubernetes?
Great question. Here are a few key best practices. 1. Use container-aware JVM flags, as we mentioned earlier. 2. Implement proper health checks in your Java applications. Kubernetes can use these to monitor and manage your containers effectively. 3. Optimize your Docker images for Java applications. Use multi-stage builds to keep your final images small and efficient. 4. Leverage Kubernetes config maps and secrets for managing application configuration and sensitive data. 5. Use Kubernetes rolling update strategy for zero downtime deployments of your Java applications. 6. Implement proper logging and monitoring solutions to keep track of your application's performance and health in the Kubernetes environment.
Those are excellent tips, Victor. It's clear that successfully running JVM applications on Kubernetes requires a good understanding of both technologies. Now, before we wrap up, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly, Sheila. The primary challenge in resource allocation for Java applications in Kubernetes is managing memory effectively. This is different from many other types of applications because the JVM has its own memory management system, including garbage collection. The JVM may see all the resources on the host machine rather than just what's allocated to its container, leading to potential overallocation of memory. This is why it's crucial to use container-aware JVM flags and set appropriate resource limits in Kubernetes.
Thank you, Victor. That really ties together a lot of what we've discussed today. To summarize our main points: 1. Kubernetes acts as an orchestrator for containerized applications, including JVM apps. 2. Running JVM applications in Kubernetes requires special consideration due to the JVM's resource management. 3. Benefits include improved scalability, resource utilization, and fault tolerance. 4. Challenges include proper resource configuration and managing application state. 5. Best practices involve using container-aware JVM flags, implementing health checks, and optimizing Docker images. In our next episode, we'll be exploring serverless Java, another exciting development in the world of cloud-native Java applications. Don't forget to subscribe to JVM Internals Crashcasts and leave us a rating if you've enjoyed this episode. Thanks for listening, and see you next time.